All right, Mrs. Erickson here, talking about the last section for Chapter 10, looking specifically at water. Describe the structure of the water molecule. That should be slight review, physical properties associated with water. Again, also slightly review, and then explain how they are determined by the structure of water. So let's take a look at the structure of water. Water is two hydrogens bonded to an oxygen. They are united by polar covalent bonds, which means they share electrons, but they don't share the electrons equally. As a result, we do get a bent shape for a water molecule where oxygen is slightly negative and hydrogen is slightly positive, and so this molecule is considered dipole because it has a positive and a negative end. And because of these differences in charges, these slight differences in charges, they tend to attract other water molecules through hydrogen bonds, as you can see in this picture right here. And in this picture, you can see that one water molecule can interact with 4 to 8 different water molecules through hydrogen bonds. Now, molecules in a solid or liquid water are linked through hydrogen bonds. It's part of the reason why ice is less dense than liquid water and ice floats, because as it arranges itself in a crystallated structure, there are like these little microscopic air pockets, making ice less dense. And liquid water, they also interact because, they're in closer proximity, and they tend to flow and glide past each other. And with hydrogen bonds, as a result, water has kind of a very high boiling point. So H bonds decrease as your temperature increases. Ice molecules, sorry, my daughter just rushed in here. Ice molecules are arranged in a hexagonal arrangement where it's interacting with between 4 to 8 different water molecules. So you can see here liquid water interact in positive to negative, and solid water, these little microscopic air pockets. Now, the molar enthalpy of water determines many of its physical properties. So I'm going to talk about fusion and vaporization. Remember, molar enthalpy of fusion is going from a solid to a liquid, and it's quite large compared to other solids because, again, hydrogen bonds. Water expands when it freezes. It has this open, rigid structure. Ice floats in liquid water, very important in the ecosystem. That's why I put little asterisks there, because I'm supposed to talk about the biological implications of that. If ice did not float, there would hardly be any life in the lakes, because if ice froze from the bottom up, and I'm just thinking about Lake Traverse and how shallow it is, how it would, it would be a bad thing. Molar enthalpy of vaporization is going from a liquid to a gas, and it's very high compared to those that are nonpolar due to strong hydrogen bonds. So steam can store a great deal of energy as heat, and the implications there is that, it's actually, think about what life is made up of. Cells have like 70% water in them, and so water can actually store a great amount of heat and maintain homeostasis. So the role of water in chemical and biological systems. Physical properties. Water is one of the few naturally occurring liquids on the planet. It can exist in all 3 states, which is an awesome thing for us. It can also store heat. It's the reason why we have ocean currents and different climates. Like we have the Gulf Stream that brings warm water from the equator up along the eastern coast of the United States across the Atlantic to Great Britain, and Great Britain sits at a higher latitude than we do, but their winters are milder compared to ours because of that warm water from the equator, from the ocean currents that they experience. Well, we don't, so our winters tend to be cold and bitter. Water is also transparent, odorless, tasteless, and colorless for the most part. Biological systems. Water is a great medium for chemical reactions to occur in cells. It helps to regulate electrolytes, especially sodium and potassium, and it can also be used for medium for transportation. You have water, in our circulatory system, and water is polar, so a lot of medicines tend to be polar, so it can dissolve and be carried through your circulatory system to different parts of your body. Chemical systems that water can be involved in. Water is the universal solvent. Give water enough time and water will pretty much dissolve anything. It's also a great coolant. So like I said, it can store a large amount of heat, and then it can also participate in numerous reactions. So yeah, water is pretty important. So that does it for the properties of water. A little bit shorter lecture. Your test format, if I'm not mistaken, I just created it yesterday, is 25 questions, multiple choice, and a phase diagram that you just have to label parts of, like the critical pressure, the boiling point, solid, liquid, gas, all that basically. So yeah, that's your test.